Hi, we continue discuss on chapter 2, subtopic projectile motion, exercise 5 for number 2. The transport plane traveling at a constant velocity of 50 meter per second at an altitude 300 meter releases a parcel when directly above a point X on level ground. Calculate the time flight of parcel, velocity impact, the distance from X to the point of impact. Okay, we analyze these questions. So we have magnitude of U is equals to 50 meter per second at angle theta is equals to 0 degree from horizontal. Let's say this is the initial position and this is the final position. So altitude ini adalah ketinggian. Daripada nilai altitude kita boleh dapat nilai vertical displacement initial to the final. Tapi nilai SY ini adalah negative 300 meter. Why negative? Because the final position is below the initial position. We don't have horizontal distance from initial to the final, iaitu SX, kita tiada. So untuk kita dapatkan jawapan bagi soalan A, the time of flight from initial to final position. Okay, untuk lebih cepat solution kita terus pergi kepada konsep komponen Y. Kita juga ada konsep bagi komponen X. So kenapa kita terus pergi kepada komponen Y? Sebab kita ada SY. In komponen Y, konsepnya adalah uniform acceleration under gravity. Acceleration is equals to negative G. So kita boleh apply tiga formula ni. We listing the formula. V is equals to U minus GT. Second formula S is equals to UT minus 1 over 2 GT square. And third formula is V square is equals to U square minus 2GS. Because in Y component, so we specify the symbol for Vy, Uy, Sy, Uy, Vy, Uy, and Sy. Which formula we have to apply to find the value of T? We have Sy. We have to find T, so we go to formula number 2. Kita tulis balik Sy, Uy kita kembangkan. Kita tulis in bracket U sin theta T minus 1 over 2 GT square. Okay, kita buat gantian. Negative 300 is equals to 50 sin 0 degree times T minus 1 over 2 G 9.81 T square. Sin 0 is 0. So equation ni akan jadi negative 300 is equals to negative 4.905 T square. Solve this mathematics. We got T is equals to 7.82 second. Okay, now question B. The velocity impact. Okay, objek ni bila flight release objek ni, objek sebenarnya akan travel dengan direction yang sama dengan flight ni dan velocity yang sama at the initial position yang ni. So bila objek ni just before touch the ground, velocity of impact of the parcel ni, the magnitude of velocity tu, okay, kalau kita bina macam graph lah, pada point, final point ni, this is the y-axis, this is the x-axis, okay, y, x. Just before touch the ground ni, vector velocity directions adalah dalam arah ni. So untuk dapatkan V, resolve bagi V ini in y direction adalah Vy. In x direction adalah Vx. We look component x for V. Vx is always constant at any point along the path travel. So Vx is always equal to Ux. Okay. Vx, saya tulis kat sini, Vx is always equal to Ux. Maknanya Vx is equals to U cos theta. Vx is equals to 50 cos 0 degree. So we got Vx is 50 meter per second. Actually, the value magnitude of Vx is negative. Negative. Why negative? Because Vx is to the left. Vx is to the left. Okay. Now we look at Vy. How to find Vy? Concept of projectile motion in component Y. I repeat. Component Y, concept is constant acceleration. Is constant acceleration. So we can apply these three formulas. Saya tak tulis baliklah sebab saya dah tulis pada soalan A. So kita nak dapatkan Vy. Apa yang kita ada? Kita ada T. Vy kita nak dapatkan. T kita dah dapatkan dalam soalan A tadi, 7.82 second. Kita ada U, kita ada G. So yang paling cepat lah kita gunakan equation number 1, iaitu saya tulis balik equation ini. Vy is equals to Uy minus GT. Kita kembangkan Uy. Okay. So Vy is equals to, in bracket, U sin theta minus GT. Kita buat gantian. Vy is equals to 50 sin 0 minus 9.81 times 7.82 second. So we got Vy with negative sign because downwards. Vy is downward direction, must be matched. The calculation should be negative. Answer. So Vy is equal to 76.71 meter per second. So we got Vx and Vy already. To find V, so like theorem Pythagoras, kalau kita bina parallelogram, sisi V inilah sisi C. Jadi Vy, sisi A, Vx, sisi B. So kita boleh apply theorem Pythagoras to calculate magnitude of V. V is equals to Vx square plus Vy square square root. So V is equals to negative 50 square plus negative 76.71 square root. So we got magnitude V is equal to 91.57 meter per second. How to find the direction of magnitude V from horizontal? So we have to calculate angle theta from horizontal x. You can apply sine, cos or tangent, but normally we apply tangent theta. Tangent theta is equals to Vy divided by Vx. Okay. Negative 76.71 divided negative 50. Shift tangent theta, we got 56.9 degree. Then should be right below negative x axis. If we refer to this xy axis, the vector magnitude V is below negative x axis, 56.9 below negative x axis. Okay, last question C. We can see the distance x to the point of impact. That means we have to calculate dia punya horizontal distance, horizontal distance x. So we go to component x. Concept component x. Component x konsepnya, I repeat, constant velocity. Constant velocity. So we can apply formula from form 4, V is equals to S over T. In x component, Vx, Sx. So rearrange Sx is equals to Vxt. Because of Vx constant in horizontal, so Vx is always equal to Ux. Is always equals to U cos theta. So Sx is equals to U cos theta in bracket times T. U kita ada, T kita dah ada. Kita dapatkan T daripada A tadi. So just ganti Sx equals to 50 cos 0 times T 7.82 second. We got Sx is equals to 391 meter. Okay, that's all. Thank you.